Good morning, everyone. Section 5.4. Start by reminding you guys that, sorry for the bell, square root of 25 is looking for what times itself is equal to 25. Well, you guys know the answer to that. The answer is going to be 5. 5 times 5 is 25. What times itself is 36? 6. What times itself is 8? Well, we've been practicing with this in section 5.3. You guys know by prime factoring it, that's 2 cubed. So it's 2 square roots of 2. And you may be asking, well, wait a minute, times itself? Really? That's 8? Yep. 2 square roots of 2. 2 times 2 is 4. And my 4s always seem to close on me. I wish I could figure out what that's doing. And square root of 2 times the square root of 2 is the square root of 2 squared. And as you guys know, square and square roots cancel out. So you have 4 times 2, which is 8. All right? So 2 square roots of 2 would be the simplified. Same thing with the next one. You guys know from the work we've been doing, that's 2, whoops, not 2, it's 3. 3 cubed. So you're square rooting 3 cubed, so that becomes 3 square roots of 3. Now what makes it more interesting is what happens here. It's looking for the same number times itself. So 5 times 5 is 25. Negative 5 times negative 5, a heck of a multiplication symbol, is 25. It has to be the same number times itself. So far, we don't have a number that can describe this. We don't have a number that can describe any of these, which brings us to the new number. I is worth the square root of negative 1. Similar to like pi is an actual number. It's a symbol, but it's an actual number, 3.1415, blah, blah. Okay? I isn't a variable. It's a number, like pi is a number. I is the square root of negative 1. So I squared is the square root of negative 1 times the square root of negative 1. Now, a lot of you may be tempted to bring those together and get the square root of 1. That's not true. You could only bring those together when they're the same number, like the square root of 2 times the square root of, sorry, when they're both positive, that's what I meant to say, is 2 times 3, which is the square root of 6. That's only legal if what's inside is positive. When what's inside is negative, you can't bring them together. Why? Because it just doesn't work. It's not the rule. The rule says you can bring them together when what's inside is positive. So think of it this way. It's the square root of negative 1 squared. And a square cancels a square root, so I squared is negative 1. So I is the square root of negative 1, and I squared, that's supposed to be the dot on the I, is negative 1. Okay. So solving this, square root both sides, and you get x equals, and don't forget, when you put an even root on the page that wasn't there before, a plus or minus shows up. And then you have the square root of negative 16. Now the longer way to do this, and I'm going to show you the shorter way, is that's plus and minus negative 1 times 16, and you can split this into 2 separate roots. Okay? You can break it apart. Square root of negative 1 is I times square root of 16 is 4, so your answer is x is equal to plus or minus 4i. And you think of I like a variable at that point, and you write it after the number. Okay? Subtract the 4 from both sides, and you get x squared is equal to negative 20. Square root both sides. And I promised you guys a shorter way to do it. When you see a negative inside an even root, it pops out as I. It comes out as I, because you're bringing it out as the square root of negative 1. In square root of 20, you guys know the square root of 20. One way to think of it is 4 times 5. Heck of a 4. My 4s just go crazy. So that's 2 square roots of 5. So x equals plus or minus, I is going to fit right here between those two numbers. 2I square root of 5. Okay, that's the order that you'd write it. So add the 4 to both sides. So you get x squared is equal to negative 12. Square root both sides. X equals plus or minus I squared of 12. 12 is 4 times 3. So x equals plus or minus 2I squared roots of 3. Subtract the 5. Square root both sides. Plus or minus. You're going to have an I inside, or a negative inside a square root. So you pop it out as I. And the 5 doesn't reduce, so that's it. I'm going to pull the x squared to this side. And the 5 to the other side. So you have negative 12 is equal to 3x squared divided by 3. And then square root both sides. Plus or minus 2I equals x. This one divided by 2. Square root both sides. Just like in the last one. So that was 2I. Add the 4 over. X is equal to 4 plus or minus 2I. Okay? It's asking you to perform the indicated operation. Well, this is called a complex number. It has a real piece and an imaginary piece. And the imaginary piece has the I with it. Unfortunately, yeah, it's called an imaginary number. But is it really imaginary? No. It just happens to have a bad name. When you're adding these together, think of these as I is like x. If I gave you 5 plus 3x plus 2 plus 4x, you guys would just add like terms. Okay? So you get 7 plus 7x. Alright? I is really no different when you're adding or subtracting. Think of it like a variable. Now it's not a variable, but think of it as one. Okay? So you have 7 plus 7i. You're subtracting, so minus 2 minus 4i. I've just distributed the subtraction through the parenthesis. 5 minus 2 is 3. 3i minus 4i is minus 1i, so minus I. So there'd be minus 3 plus 8i. So there's 5 minus 3 is 2. I plus 8i is 9i. I plus 11 minus 5i. So we have 11 minus 4i is the answer. Here you're multiplying. This distributes in. 4i plus I squared. Now remember back a couple pages. I times I. That's square root of negative 1 times square root of negative 1. And I said that thinking of it that way led you a little bit astray because you had to remember you can only combine these when what's inside is positive. So thinking of it as perhaps this way. 1 second. I squared is the square root of negative 1 squared. The square cancels the square root, so you get negative 1. So 4i plus I squared is really 4i plus negative 1, and it's supposed to be written the piece without the I first, so negative 1 plus 4i. Okay. This would distribute inside, so that would be negative 3i plus 6i squared. I squared is negative 1. So it'll be negative 3i minus 6. So then you rewrite it, minus 6 minus 3i. Okay, this would distribute inside. Minus 12i plus 8i squared minus 12i plus 8 times negative 1 minus 12i minus 8. The minus 8 needs to come in front. 12i. Okay, now these, you would just FOIL them. So 10 plus 20i plus 12i plus 12i squared. Whoops, 6i. I don't know why I wrote 12. Carried away. Sorry about that, you guys. 6i inside. So you have 10 plus 26i plus 12 times negative 1. So that becomes negative 12, and there's a 10 that can go with it. So negative 2 plus 26i. FOIL it. 15 minus 40i plus 3i minus 8i squared. 15 minus 37i plus 8. So that would be 23 minus 37i. Okay. Let me extend this page a little bit. Give me a little more room at the bottom. Okay. Now remember, guys, when you have a perfect square like this, that really means 5 plus I times 5 plus I. So you have to FOIL it. So you get 25 plus 5i plus 5i plus I squared. I squared is negative 1, so we have 24 plus 10i. Seeing the same thing again. 5 plus 3i. 5 plus 3i. So you have 25 plus 15i plus 15i plus 9i squared. So that would be 9 times negative 1, which would be negative 9. So that would be 16 plus 30i. Okay. I think that's all that you guys have for the first part.